Hi everybody, my name is Thomas Nacht. I'm from Forward Energy Research, and I would like to show you today a little bit about our Y project. So let's first off talk a little bit about myself. I'm just kidding, just some brief information. Again, Thomas Nacht, my name. I work for Forward Energy Research, which is a small research company based in Graz in Austria, with a strong focus on energy-related research in different national and international research projects. So, and today I have the great opportunity to present to you the Y project, which is an H2020 funded project focusing on simulation of energy consumption. So when we talked about energy consumption in the past, we realized that there is a strong current household energy models lack a certain degree of detail. They are either represented by standardized load profiles, pardon my English, or more sophisticated models, but they don't get quite to the core of how household members actually think and decide. And this is a huge problem for energy system models, which are used to simulate large-scale energy systems. So for instance, if you want to know how the energy system in 2050 would look like, you would consult an energy system model, which is a mathematical model for the entirety of, for instance, the European energy system. So that was our background why we decided to make the Y project, and for that we defined a set of different objectives for this project. So first off, the main objective, of course, is to improve the quality of energy system models by making a more precise consideration of households. What does this mean? Precisely that we analyze different parts of household energy consumption and energy generation on a more detailed level. This comes down to energy efficiency, distributed generation such as PV or small scale wind or H2 generation, also demand response and electrification of services. So for instance, if you think about heating with electricity via a heat pump or electrical mobility and stuff like that. So that's electrification of services. And we wanted to analyze electrical consumption in households more precisely, but not only the technical side, but we also wanted to consider the behavior of people that actually use different services to satisfy their needs. So for instance, what happens to a household if the parameters surrounding us change, like for instance new laws are introduced, or there are new fundings. We subsume all these changes as interventions in the project. So we also want to consider that path, and we also want to have a more sophisticated analysis of the social behavior of people living in households, which then use the different services to satisfy the needs, as I've mentioned, and then create an energy consumption. And that way we want to bring user behavior inside energy system models. And of course, as for each research project, we want to spread our knowledge, but not only to policymakers and society, but also to the general population through large-scale and ambitious communication activities, and further on also exploit the research projects for further research, but also for commercial use. So when I speak of the Y consortium or the Y project, there are quite a few actors involved. We have one university, 3 research organizations, 1 SME, 1 industry, and 2 NGOs, with a wide distribution across Europe. You can see the different partners of our projects by their logos in the slide at the bottom of the slide, and their geographical distribution on the left-hand side. And to further validate our results, we also have an advisory board, which gives us, as the name indicates, advice to our research parts. That stems from Europe and across Europe and the borders of Europe. So how are we going to tackle that issue of considering socioeconomic factors, behavior, decision making, and electrical consumption in one model and then upscale it? Well, basically, the concept for the model is on the slide you see right now. So we have the behavioral model, which is the first part of our simulation, where all that consists of two main parts. First off, we have the model that describes the everyday behavior of people, and the second model, which describes the reaction of people to set interventions. So for instance, how would a household react if a new funding system would be implemented? How would a household react if new laws were implemented? And how would they change their behavior? All this information then gets fed to our energy services models, which basically is nothing else than a technical representation of a household and the devices in the household. And for each group or for each behavioral group, we then simulate the energy consumption. And to get from individual households to a large scale energy systems, we have to upscale everything, which is part of the upscaling part, as the name indicates. And then this information gets fed into the energy system models, which then considers the rest of the energy system. So, for instance, large-scale generation, or industry, or the electricity grid, for instance, or also the markets. And that's then the result of, and from that we can have different results for the project or for our energy system modulation. More in detail, so the behavioral model will build on the methodology of forma and causal models, for both of which I'm not an expert, but you can read about that in publications that will be made from the project in due time. Then the part which I'm responsible for is the energy services model, so where we translate people's behavior into technical behavior of devices and energy consumption. So we have different appliances that we simulate there, and also different aspects such as demand response, home automation system, but also electric mobility or power to X technologies, and so on and so forth. In the upscaling system, we, as I mentioned, bring everything to a large scale system. But the issue here is, if you think of Europe, for instance, there are millions and millions of households. You wouldn't be able to simulate each household for itself, so you have to make clusters of households and then upscale them correctly. So for instance, there are 1 million households of cluster A, 2 millions of cluster B, and so on. So that's what the upscaling model does. And then we will create the corresponding plugins to three of the most important energy system models, which is Times, Primes, and Prometheus. And this will be done also in the project, so that we also can make large-scale simulations. In order to validate our results, we have 5 different use cases developed, all with different sizing and different objectives. So on this very small scale, we have the Gniebing microgrid, which is Gniebing is a small hamlet in Austria, which has a interesting focus on blackout prevention. So the grid operator there has already installed generation capacity and switching capacities to supply critical infrastructure during a blackout situation. And there's an overproduction capacity, so we would analyze if there's the possibility to add additional households to the blackout supply case. And also for that, we need better load profiles, and also the information on how people would react during a blackout. The energy cooperative, where we will analyze new load profiles for normal operation, and also test and validate different new policies and tariffs for the for the utility providing the energy. The energy community case, our third case, focuses all around renewable energy communities, which is a new possibility to collectively generate and consume energy in Europe. So there we will create tools to better understand how energy communities would work, how people would behave, and how we would design interventions to foster foster a higher use or participation in energy communities. For the 2030-2050 European strategy, we shift things into overdrive and look at Europe as a whole and create different load profiles for different scenarios and for different interventions. And then assess how they would affect the European scale level. The same goes for the global scale, where we will have a worldwide simulation until 2100 with the same targets, basically. So how are we going to do that in a more detailed way? First of all, we have to identify different energy behavior profiles. As I mentioned before, we can't simulate every household for itself, so we're doing some clustering. Then we compare the energy behavior profiles with the socio-economic profiles. That process is already concluded. And then we're starting defining different interventions for each year. If there is an intervention, if on a long scale, there might be some years where there are no interventions at all. And then we use, for each of the energy behavior profiles, so for each of our clusters, we will use the causal models to decide whether or not there are investments based on the interventions defined in the scenario. And then we will see how those investments or how those changes affect the energy consumption of the household. So that's basically that part, and from there we will try to upscale everything and bring it to a larger scale in order to simulate the effect it has on a large scale energy system rather than on the individual household. And from that we will get the required feedback and inputs to assess everything. The model itself will be set up from different parts, which can be seen in this slide here in the diagram. So the first step of the simulation is the causal model, where the decision of the individual households are made and which affect then the consumption. The decisions made will affect the non-controllable renewable energy, also the load profiles. We have the LPG, which stands for load profile generator for electrical, transport, and thermal energy. And we have the building sizing algorithm, which whenever there is the decision to invest into something, the sizing of this investment has to be made. So for instance, if I invest into a PV plant, how large will it be? That depends on different factors like size of the house, size of the roof, inclination of the roof, and stuff like that, available money, existing consumption values, and stuff like that. All that information will go into the building sizing, and then the optimal sizing of the investment will be calculated. If that's done, we do a whole house infrastructure simulation, which basically is for each of the clusters defined, we simulate the household consumption. Then again, as I mentioned, the upscaling and the different use cases with different ways of processing the results gained and even optimizing interventions if need be. We have different run modes for the models. We have the building sizing loop. As I mentioned already, this is the loop where we decide, okay, we want to make an investment, and this investment will be a PV plant, and for that we need to invest into a PV generator, and how large should it be. We have the intervention optimizer loop, where we look at different interventions, or we set an intervention and optimize the effect of the intervention. So for instance, we have new taxes or new subsidies, and we want to change the parameters of these taxes and subsidies and look how they would affect or what effect they would have, and see then, okay, what the optimal parameters would be for said intervention. We have the use case loop, where we look at the different objectives of the use cases I mentioned earlier, and we have the counterfactual loop, where we look at one important thing or one interesting thing about the past. Like, for instance, if a certain intervention did not happen in the past. Like, for instance, there would have been no funding for renewable energy, or PV, small scale PV did not exist. What effects that would have had on our energy system? What would have happened to the investment on the people that would have wanted to invest into something? Would they have invested into something else, and stuff like that? So we take one certain aspect of the part and analyze its effect it has on today's life. So that's it in basic. That's it basically for the Y project. I hope I presented you a good and short overview, and kindled your interest in the Y project. Thank you very much for your attention, and have a great day.